Every managed Postgres bolts compute onto storage. Azure HorizonDB rips them apart. That one split is why it survives a zone failure without losing a committed write. This is for architects running mission-critical OLTP and AI workloads. Committed transactions persist across zones before the acknowledgement. Today I dissect the architecture and the failover trick that needs no write-ahead log rewind. Note it is in preview, so check current Azure docs. Start with the core idea, database as a log. In classic Postgres, a commit lands on a local disk tied to one node. HorizonDB sends commits to a shared, zone-redundant write-ahead log service instead. Storage no longer belongs to a single machine. That means compute and storage scale independently. Compute reaches roughly 3072 virtual cores. Storage stretches to about 128 terabytes. And it stays fully compatible with PostgreSQL 17. The gotcha hides in failover, 2 scenes away. A cluster has one primary handling reads and writes. Alongside it sit one or more readable high-availability replicas. Azure auto-places them in different availability zones. Below the compute tier lives shared storage. First, the zone-redundant WL service accepts every commit. A data storage fleet then asynchronously applies that WAL. Finally, zone-redundant blob storage anchors durability. No compute node owns the data. Every replica reads the same durable storage underneath. Here is the durability contract. A write is not acknowledged until the WL persists across zones. So a committed transaction physically exists in multiple availability zones. Lose an entire zone, and that write is still there. This is the foundation for the failover payoff next. In-flight transactions that never committed roll back per ACID. You never see partial or phantom data. Now the payoff. In traditional Postgres, promoting a standby means replaying or rewinding the write-ahead log. That takes time and risks losing recent writes. HorizonDB skips it entirely. Every replica already reads the same shared durable storage. So a promoted standby already holds every committed write. No WAL rewind. No primary reinitialization. Failover completes in seconds, not minutes. Committed transactions are never lost. Now build against it correctly. Do not connect to a specific replica's address. Use the read-write endpoint for writes and the read-only endpoint for reads. Those endpoints reroute traffic automatically after a failover. Your application follows the new primary without a config change. Still, wrap calls in retry logic with exponential-backoff. A few connections drop during the brief promotion window. Here it is in code. Point your connection string at the read-write endpoint host. Wrap operations so transient failures retry automatically. Keep backoff bounded so you fail fast when something is truly down. Recap the design. Disaggregated compute and storage over a database as a log model. Commits persist across zones before the acknowledgement. Failover promotes a standby with 0 WL rewind in seconds. Connect through endpoints and add backoff, and failover is invisible. Remember, this is in preview, so verify limits and pricing in the current Azure docs. If this breakdown helped, subscribe for more architecture dissections. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.